So Assalamu alaikum students, I hope you are all doing well and welcome to this new video. And remember, in the previous video I was talking about the static game with incomplete information and we get some basic ideas. We did an example and we also found the Bayesian Nash equilibrium. So in today's video I'm going to continue this chapter, and today I'm going to show you a simple way to find the Bayesian Nash equilibrium. Okay. So let me start this video by first explaining you the Bayesian Nash equilibrium, which we did in the previous lecture. So according to the definition of Bayesian Nash equilibrium, a Bayesian Nash equilibrium is a set of strategies. Okay, so in Bayesian Nash equilibrium we will be telling about the strategies of the player, but one for each type of player. Remember, there is some uncertainty, there is some incomplete information, and so we have types of player. So we have to explain the strategy for each type of player such that no type has an incentive to change his or her strategy. Okay, same like Nash equilibrium, there is no incentive for each type of player given the beliefs about the types. And as you know that there are some incomplete information, one player do not know about the types of the other player, so it means there are some beliefs. So we have to take that beliefs into our consideration when we are finding the strategies. And then of course we will be finding a strategy considering what other types are doing. Okay, so this is the definition of Bayesian Nash equilibrium. So as you have noticed that the Bayesian Nash equilibrium are more complicated than Nash equilibrium. Why? Because we have to find the strategy for each type of player. Okay, and then we are actually having some simple tools to use Nash equilibrium to find Bayesian Nash equilibrium for strategic games. So we will try to rewrite our game such that we can use Nash equilibrium to find Bayesian Nash equilibrium. So this is what I'm going to explain you in today's video, how to do it. So now I'm going to show you how to find Bayesian Nash equilibrium using the idea of Nash equilibrium, and we will be understanding it with the help of an example. Okay, so in this example we have two players. Okay, player 1 and player 2, and for player 1 we have only one type. Okay, but for player 2 we have two types, type A player 2 and type B player 2. Okay, so it means that player 1 has some incomplete information about player number 2. So when player number 1 is playing game with player number 2, he do not know if the player number 2 has type A or if he has type B. So this is the situation of the incomplete information. And then player 1 has some beliefs. Okay, some beliefs, some knowledge about player number 2 types. So he knows that probability of type A is 0.2 and probability of type B is 0.8. So he has some beliefs. He has some prior beliefs about the types of the of player 2. Of course, player 2 do not need any beliefs. Why? Because he know what is his type. But the incomplete information is for player number 1. So now let us look at the payoff matrices. So you see here that player 1 has two types, type A and type B, and the probability of type A is 0.2 and the probability of type B is 0.8. And here we have player number 1 and here we have player number 2. So and then we have the payoff matrices for each type of player 2, and this is the payoff if the player 2 is type A, and these are the payoff if the player 2 is type B. So basically in now we have to transform this, these two weight matrices, two payoff matrices into one big matrix where we can find the Nash equilibrium. And if you look at player 1, so he has only one type, and player 1 has only two strategies. He can choose up or down. But if you look at player 2, then we have to know if what he is doing if he is type A and what he is doing if he is type B. So we have to write all the possibilities for player number 2. So for example, this LL means that he is choosing L for type A and also L for type B. And then this next possibility here, LR, means that he is choosing L, okay, for type A, and he is choosing right for type B, because we have to write all the possibilities for player number 2. And similarly, this LR means that he is choosing R from type A and L from type B, and finally RR means that he is choosing right from both the types. So once we are able to, I will show you how to find the numbers here, but once we have all the numbers here, all the payoffs here, we will then use the idea of Nash equilibrium to find the solution for this game, which will be called Bayesian Nash equilibrium. So now we can use these two payoff matrices to find the numbers here. So we first try to fill out if player 2 is choosing LL and player 1 is choosing up. So this is player number 1 and this is player number 2. So if player 2 is choosing, if player 2 is type A, then the payoff for player number 1 is 3, and if he is type B, then again the payoff is equal to 0.8. So basically player 1 is not sure about the payoffs. So what we can do, we can calculate the expected payoff. Okay, and we are doing it for up and then L. So how do we get it for player number 1? It is 3 times 0.2 plus 3 times 0.8. So if we solve it, we get the answer is equal to 3. And this is for player number 1. Similarly, if player A is type A, his payoff is 3, and if he is type B, his payoff is 3. So we can also find the expected payoff for player number 2. So it will be equal to 3 times 0.2 plus 3 times 0.8, that will be equal to 3. Okay, so now we can substitute these 3 here. Okay, so I hope it is clear. And then we can find the numbers for LR. So again, we are calculating expected payoff. For up and L. So again, so what do we have to do for player number 1? So player number 1 is getting for playing left he is getting 3 here, okay, and then for right he is going to get 0. Okay, so this is if he plays up, and the player 2 is type A is playing L and type 2 is playing R, so it means he can get either 3 or he can get 0. So we can calculate the expected payoff. 3 times 0.2 plus 0 times 0.8. So how much is that then? 3 times 2 is equal to 0.6. So this is for player number 1. So if we look at player number 2, then he is left right, so it means he can get this payoff, or he can get this payoff. Okay, so now we can again calculate the expected payoff. So it will be equal to 3 times 0.2 plus 2 times 0.8. So how much he gets? He gets 0.6 plus 1.6. So the answer will be equal to 2.2. So this is the payoff for player number 1, and this is the payoff for player number 2. So now we can write these numbers here. So it will be 0.6 and 2.2. So let me show you one more, and we can do a for L and down. You have to do it for every number here, and you can do it very easily. But let me now show you for down from player number 1 and RL for player number 2. So expected payoff for down and RL. Okay, so now we have to look at this down, okay, and RL. So it means this one and this one. So if we look at player number 1, so he can get 1 with probability 0.2, and he can get 2 with probability 0.8. So if we calculate the expected payoff, so it will be 1 multiplied by 0.2, the probability, plus 2 into probability 0.8. So what do we get then? 0.2 plus 1.6. So the answer is 1.8 for player number 1. And similarly, we have to do it for player number 2. So for player number 2, he can get 2 with probability 0.2, and he can get 0 with probability 0.8. So now let us write his expected payoff. 2 times 0.2 plus 0 times 0.8. So the answer is 0.4 plus 0 is equal to 0.4. So this is the payoff for player number 2. So now let us write the numbers here. 1.8 and 0.2. Sorry, 1.8 and 0.4. Okay, so this way you can find all the numbers here. It's very easy. You just have to calculate the expected payoffs. So once you do the calculation for everything, you get this full matrix with all the expected payoffs. Okay, so now what we have to do, we have to find the Nash equilibrium in this game. So if you find the Nash equilibrium in this game, we call it Bayesian Nash equilibrium. Okay, so how do we find the Nash equilibrium? We have we can use many different methods. We can for example use the idea of removing the dominated strategies, or we can check each number one by one. So whatever method, or the best response function, so you can use any method to find the Nash equilibrium of this game. But let us now use the removing the dominated strategy. So if you look at the payoff so let me show you in the highlighted way. So if you look at the payoff from LL and RL, so what do you see? That for player number 2, this strategy is always giving higher payoff compared to this one. So RL strictly dominates LL. Okay, so R, or I can write it RL, is always giving higher payoff than LL. So it means we can remove LL from the game. We can remove this. We can remove this LL from the game. So if we do that, we get the reduced game. So we get this game here where we removed LL because LL is dominated by RL. So now we further investigate for player number 2. So if you look at this strategy here, RR and LR, so what do we see again? So this number is bigger than this, and this number is bigger than this. Okay, so what do we see? We see that RR is strictly dominating LR. So again, we can remove this LR from the game. Okay, so you can see here, this one is bigger than this one, this is bigger than this one. So we can remove LR, and then our game is left with this smaller game. So now if you try to find the strictly dominated strategy, there is nothing. For player number 1, there is no strictly dominated strategy, and for player number 2, there is no strictly dominated strategy. So what we can do now, we can use the idea to see if there is. So we see one by one. So first let us look at this, if this is a Nash equilibrium or not. So if we look at player number 1, so he is getting 2.4 here. If he deviates to down, he gets 1.8. So there is no incentive for player number 1 to change. If we look at player number 2, he is getting 3.2 here, and if he changes to RR, he gets 2.4. So there is no incentive. So it means RL is Nash equilibrium. Okay, and we call it Bayesian Nash equilibrium. Okay, we call it Bayesian Nash equilibrium. And then we look at this here. We look at this here. Okay, so let me change different color. So now we are looking at this. Okay, so if we look at player number 1, so he is getting 0 here. If he changes, he can get 1. So of course there is an incentive. So he would like to move to the down. And we can also check for player number 2. So he is getting 2.4 here, and if he changes, he gets 3.2. So both players have incentive to change. So it means this is not a Nash equilibrium. And then if we look at this one here, okay, and again if you look at player number 1, he is getting 1.8 here. If he moves, he gets 2.4. So this is not a Nash equilibrium for player number. There is an incentive for change for player number 1. If you look at player number 2, he is getting 4 here. If he changes, he gets 1.2. So again, this is not a Nash equilibrium for player number 2 as well. So this is not Nash equilibrium. And finally, we can look at here. So we look at this one. So if we look at player number 1, he is getting 1 here. If he moves, he gets 0. So there is no incentive. So this is fine for player number 1. If we look at player number 2, he is getting 1.2 and here is 0.4. So it is also fine for player number 2. So what do we see here? Sorry, for here it is up and RL, and here this one here is down, and RR is a Nash equilibrium. But remember, this Nash equilibrium is now called Bayesian Nash equilibrium. Okay. But remember that every game has odd numbers of Nash equilibrium. So we found two pure strategy Nash equilibrium. So one is this is pure strategy Bayesian Nash equilibrium. This is also pure strategy Bayesian Nash equilibrium. But you can also find a mixed strategy Nash. Remember, there are 3 Nash equilibriums, so one will be in mixed strategy. So if you do the calculation for mixed strategy, so you will find that with probability 1/2 and 5/8, there is a mixed strategy Nash equilibrium. So this is P. So let me write it. You can practice it and you can show me your result. So it will be 1/2, and then 5/8 and 3/8 is mixed strategy Bayesian Nash equilibrium. So we find 3 Nash equilibriums, 2 in pure strategies and 1 in mixed strategy. So I have 2 homework questions for you. This is homework 1. So you have to find Bayesian Nash equilibrium for this game, and then you have homework number 2. This is homework number 2, and you have to find the Bayesian Nash equilibrium. So it will be very good for your practice. Okay, and I will send you the answers once you have done it. Okay, students, I hope you now understand how to find Bayesian Nash equilibrium, and try to do the practice questions or homework question 1 and 2, and thank you very much for listening.